Welcome to EDU World Space.
For this question, we've been given our sample size is 24, so n equals 24. The sample standard deviation given is 4.8. Since n is 24, the degrees of freedom in our case is 23. And since we're finding a 90% confidence interval, alpha is 0.1. Now using these, we can find the two critical values from the G-table. Chi-square alpha by 2 in our case is chi-square 0.05 with degrees of freedom 23. If you check the G-table, this value is 35.1725. Chi-square 1 minus alpha by 2 in our case is chi-square 0.95 with degrees of freedom 23. If you check the G-table, this value is 13.0905. Now that we have the two critical values, we can move on to find the confidence interval for the population variance. This here is the expression for the confidence interval for the population variance. Now, subbing the values we have, we get the lower boundary of our confidence interval as this expression here, and the upper boundary as this expression here. Simplifying further, we get the lower boundary as 15.0665 and the upper boundary as 40.4797. Now, this is the confidence interval for the population variance. Now, to get the confidence interval for the standard deviation, we take the square root of the confidence interval we found for the population variance. This means the lower boundary of our confidence interval for the standard deviation is square root of 15.0665, and the upper boundary is square root of 40.4797. Simplifying further, the lower boundary of the confidence interval for our population standard deviation is 3.8816, and the upper boundary is 6.3624. Now here we found the confidence intervals for our standard deviation and our population variance. Now, I think lifetimes mentioned are consistent with the with the confidence intervals we found, since 4.8 lies between 3.8816 and 6.3624.